Hey everybody, it's Miss Marie and I'm back to extend our fraction concepts into addition and subtraction of fractions and what it means to decompose a fraction. Decomposing a fraction basically means that we're going to take a fraction and we're going to break it up, or we're going to show that a fraction is actually already made up of sums. We're going to start with wholes, so we can look at one whole, which we know one whole can be a lot of different fractions. We're going to use 8/8 in this one, and we can take 8/8 and show that as a sum of its unit fractions. Unit fractions means when I would use just one of that piece. So this could be 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. And I'm going to do this until I get to 8 of them. 1, 2, 3, 4, 5, 6. Okay, and I can shade that in by showing 8/8 is equal to 1/8, and another 8, and another 8, and another, 7, and 8/8. So one whole is equal to 8/8, which is also 1/8 repeated 8 times. Now, that's not the only way I can make 8/8. I could also make 8/8 with 4/8 plus 4/8. I could do it with 2/8 plus 6/8. I could do it with 2/8 plus 3/8 plus 3/8. Okay, and really my options could be unlimited. We're just looking at any possible ways of adding sums that are going to give us a total of 8/8. And all of these do that. All right, here's another example. This is using one that's not a whole, so 5/6. 5/6 basically is so already our final fraction. Thinking of it as already the sum can be made up of many different addition sentences that show a total of 5/6. So if I were to model, okay, there I've shown 5/6. I'm using two different colors to show two different amounts added together. So this model here is shown as 3/6 plus 2/6. So 3/6 plus 2/6 equals my 5/6. If I were to do this as a sum of unit fractions, that would be the sixth one of them added together until I got to 5 of them. Okay, 1, 2, 3, 4, 5, 6. I could also add this together as 2/6 plus 2/6 plus 1/6. We could do this as 3/6 plus 1/6 plus 1/6. Okay, so again, any combination of an addition of sums, it's going to give us a total of 5 of those 6. Now we haven't really gotten even into the shortcut trick, or what we were taught when I was students, is what do you do when you're adding a fraction? We were told that what we're doing when we add fractions is to add the numerators and never add the denominators. Well, we've basically shown that concept without actually coming out and saying those words. We're going to talk about why we don't add the denominator and what would happen if we did that. So here's an example of an addition of two fractions. This is 3/10 plus 4/10. I'm going to show a couple different models here. We use the rectangle model quite often, and then we're also going to use some number line models. Students do not have to use either one of these models, but they do have to recognize them in pictures. If they see on a test that a model's been used, they have to be able to understand what's shown here. So this is 3 out of my 10 parts. I'm going to add to that 4 of the tenths. Okay, so how many do I have shaded together? Well, back to our last chapter, we understand the most important part of the fraction is the denominator. The denominator tells us the size of the piece. It's how many pieces the whole is broken into. This whole is broken into 10 pieces, and how many we have shaded in is 7. So eventually we're going to want students to notice the patterns here, but this is not generally logical for students. Most students are going to think, I'm going to add 3 plus 4 and get 7, but I'm going to add 10 plus 10, and that gives me 20. But that does not make sense with fractions, because if you think about it, if you're adding 10 and 10, you're getting 20, and what that denominator of 20 means is a 20th piece. That means a very small piece. So it doesn't make mathematical sense to add two pieces together and end up with a smaller piece than what you began with. So we're going to use that idea to remind students that we never add the denominators, because that would really end up with smaller pieces. And that doesn't happen when we add. So all this denominator tells us is the size of the piece we're working with. We have 3 of them and 4 of them. These are our counting numbers. These tell us how many we actually have. And so that's why we can add those numerators. On a number line, it would look like this. So I'm going to make a jump here. I have a number line broken into 10/10, which is a whole, same as my whole here. I'm going to make a jump to 3/10. 1, 2, 3. I'm going to jump 4 more. 1, 2, 3, 4 more, and then I would end up at 7/10, same as my answer up here. All right, we'll take a look at another example. This is 3/5 plus 4/5. Again, we're not going to add those denominators because that would end up with tenths, which are smaller pieces. So we're going to leave our denominator as is. I'm going to add my numerator. 3 plus 4 is 7. And here's where students might get stuck a little bit and think we have a problem with this fraction. When we were in school as kids, we used to call this an improper fraction. But it's not improper. There's nothing wrong with it. It's just a fraction greater than 1. And so we're going to show that this doesn't work to leave it this way. So we're going to take 3/5. And when I try to add 4/5 to that, it doesn't work. It's going to only add 2 of them until I get the whole. So what I'm going to do is make another whole, still broken into fifths, so that I can add the rest of my 4/5. So 1, 2, 3, 4. I can get my answer in 2 ways on our tests. 7/5, which is a fraction greater than 1, is okay. Sometimes this will be an answer choice on a multiple choice. Other times they might look for a mixed number. As a mixed number, we're going to write that as 1 whole and 2/5. And we're going to get into a review of how we turn fractions into mixed numbers and mixed numbers into fractions in just a minute. But that skill is going to be needed a little bit more in the second half of this unit. Actually, a lot more in the second half of this unit than this week. So again, this is not a new concept. We did this a little bit in Introduction to Fractions. So when that comes up, we want students to be able to convert that fraction greater than 1 into a mixed number. All right, on to subtraction. Another reason, and especially with fractions, it makes sense why we don't mess with the denominator, why we don't subtract our denominator. If I were to subtract 8 minus 8, I'd end up with a denominator of 0. You can't have a denominator of 0. That means your whole is broken into no pieces, which means it's not a fraction at all. It's impossible to have that. So if we were to shade in 6/8, and I'm going to subtract 2/8, instead of making more of them, I'm going to take some out. Okay, so I'll just take out 2/8. So what I'm left with now, I still have 8ths. My pieces, my sizes haven't changed. I'm still dealing with 8ths. Now I only have 4 of them left. It's possible that on a multiple choice, students wouldn't see 4/8 as an answer choice. We want them to recognize and remember from last unit that we can make those into a simpler form. A lot of times this will be an answer choice. Sometimes they throw it in there to trick them, to see if they don't see that, if they can find another form of that number. So it's a little bit of using multiple skills over different fraction disciplines. And we want to see if students can really work with fractions no matter how they're given to them. All right, here's the number line model. This would mean I'm going to take my number line and I'm going to jump 6/8. So this is a whole broken into 8 parts. I'm going to go 4, 5, 6. Okay, and then if I'm going 2/8, then what I'm going to do is I'm going to jump backwards 2, not going further 2. Okay, so I might do this, and then I might hop back 2 spots. Okay, if I hop back 2 spots, you see I landed at 4/8, and I know 4/8 is also equal to 1/2. All right, so again, very important this week is that we understand why we're leaving the denominators the same, because the denominator really only tells the size of the piece we're working with. So for example, in this addition question, this might come up if students were to think about it, but we will not have any questions like this in 4th grade. This is a 5th grade skill. We call these unlike denominators, and this is another extension of why we can't mess with the denominators when we're adding. If I were to add these two, most students from our first chapter If we were to tell them, yep, I've learned, all we're going to do is add the numerators, and we're going to do nothing with the denominators. Well, adding these numerators, 1 plus 3 would give me 4. But what would I use as my denominator? They're not fourths, and they're not eighths. So how do I write that? They're different size pieces. So basically the answer is you can't. You cannot add fractions if the denominators are different pieces. We will not enter any of that this year in 4th grade. That is a 5th grade skill, but we will talk about why it doesn't work, because I don't want students to think a blanket statement, because the numbers we worked with in 4th grade, that all we do is add the numerators and we don't mess with the denominators at all. So we would have to change both of these into eighths, making this a new equivalent fraction so that we could add. We also couldn't just add those two together. I can't just add 4 plus 8 and get 12, because then again I'm dealing with a smaller size piece than I even began with. So we're only going to be using like denominators in 4th grade. And again, another example of why we don't mess with the denominators. In subtraction, 6 minus 6 would give you 0. We don't want to do that. So we're going to keep the denominator common and subtract just the numerators. Okay, so we are making sure we understand that the denominator is just the size of the piece, and we're only going to be working with the numerator. If the denominators are different, that's not a problem we're going to work with for now. All right, thank you so much for watching, and go ahead and like and subscribe to my video if you haven't already.